woo! Yeah, more videos! When is this gonna stop? Well, almost. We're in like the last leg of the lecture videos, and the last leg of this particular type of module is gonna focus on utilities. So if I ask you, and we've mentioned this before together in the other videos, if you've watched them, we've measured utilities, or we've at least mentioned utilities, and we get measured with our utilities every single month. So my water bills, my electric bills, my cable bills, my phone bills, all of those are what we would call utilities that's running out of our home. And it's something, a resource that we have to use because I want my water so that way I can wash my clothes and take hot showers. Okay, well, that's also going to require a little bit of electricity in order to heat that water up. If not, I'm going to be taking cold showers, and who wants all of that? So utilities are very familiar to you as a renter or as a homeowner, and utilities are also going to happen in the manufacturing world with these companies that make and produce these types of pharmaceutical drugs or injections or whatever they have decided to manufacture. And with that is going to come a little bit of waste that we need to mention, because as we are making things, waste is getting generated. And how do we handle that waste? Where does it go? Does everything just go down the drain? Of course not, silly. We're going to have to process it. We're going to have to handle it. We're going to have to do something with it. So we're going to have to break down some of the common utilities, and one of the first ones that we're going to mention is this idea of gases. So gases are a common utility that can be used in the manufacturing line for different purposes. We're going to go through some of those, we're going to talk about those, and then we will move on to the rest of the utilities that are out there. All right, so let's talk about some of these utilities. I've already mentioned one, and the first one we said was gases. Okay, so gases, what are they? How do I use them? What are they used for? How do they get used? What happens after we use them? These are kind of the questions that we're going to have to answer throughout these lecture videos when we do them. Next is water, of course. Water is very, very common. So how do we process the water? How do we handle the water? Are there different grades of water? What goes on with water in the manufacturing line? What kind of waste does it generate? How do we treat it once we're finished with it? Where does it go after we're finished with it? Again, that's the purpose of the upcoming videos that you'll watch with me, the one and only. All right, number 3, we're also going to talk about steam. And steam, of course, is just going to be super hot water that we've heated up. It's turned into water vapor, and it's kind of carrying a hotter temperature. And steam can be used for different purposes as well. All right. Next up, throughout the upcoming lecture videos, and again, they're just going to be maybe a handful more of them, we're going to talk about clean in place, and we're going to talk about steam in place systems. So the CIP is going to be clean in place, of course, and the SIP is steam in place. So these are two things that we have to discuss. We have to talk about them, get comfortable with that kind of ideology. What's going on? Why do we use it? Why do we need it? What's the purpose in it? How do we handle it with care? And then what happens after we get finished? All right. Next up, heating and cooling systems, of course. All right. So heating and cooling systems have a place in the manufacturing line. What do they do? What's going on with those? And how do they work? Next up are hydraulics. So that's something else that we'll see. And number 7, of course, is electricity. So all of these are going to be what we would classify as industry utilities. Now, some of these you will have on your own. You will have water, you will have electricity, maybe you've got natural gas at your home, but some of these are going to be very familiar terms with you, and this is something that you can imagine in your head as we discuss and as we talk about them. But some of the others, maybe not so much. So again, we'll kind of slow down during those times in the video where we'll really flesh out this idea of what some of these other utilities are. All right. So, in other words, like I've said before, all homes require utilities. All industry requires utilities as well. And the manufacturing line, especially in the pharmaceutical world, is also going to require some utilities. So, we want to talk about them, and we want to get a better idea of what they are and what they actually do. There's actually two different categories of utilities when we begin to talk about these, and the first one's called clean, and the second one is called black. So what this means is that if a utility is classified as a clean utility, then that means that it directly contacts the substance that we're trying to make in some form or in some fashion. So if we are using a gas, that gas is coming in direct contact with the stuff that I eventually want to maybe bottle up in the end of the manufacturing line. If it does not do that, though, if it doesn't come in contact with it, but if it's used for a different type of purpose, then that is what we would call a black utility. And a black utility does not come in contact with the ingredient whatsoever, but it is used in the manufacturing line in some form or in some fashion. It just doesn't have to be, quote, clean. So sanitary and non-sanitary, we kind of go back to when we open up these discussions a little bit. And the whole idea with the popping and with the valves and all of those pumps, what can we clean them? Are they coming in contact with our active substances? Yes or no? Do they have to be sanitary? Are they unsanitary? What are they? The same kind of things happening with utilities as well. That's not surprising. So, are they coming in contact with that ingredient? Yes or no? And if they do, then they've got to be super sanitary. They've got to be super clean. And those are the two terms that we use in the umbrella of the utility world. We're first going to start off with gases. I told you that's kind of the very first one that we're going to mention. And gases can be used to do a number of different things in industry. And here are just a list of a couple of those. First, they can be used in chemical reactions. So if something's going on and we're trying to make something new, and we add two things together and we get this new product here in the very end, and we want that new product. Yeah, all right, we got money, and we got money in our paychecks. Well, then gases can be used in order to drive that reaction forward. So sometimes they are needed in order for that product to be formed. So number one, in chemical reactions, we're going to see gases that can be used for that type of purpose. Number two, they can also provide the power to operate various valves. So we went through this kind of lengthy discussion of the fermenters and the bioreactors and the popping and the valves and the pumps. And in that kind of brief moment where we talked about valves, brief? Are you kidding me? You spent like hours and hours talking about valves. I know. Just give me the benefit of the doubt. But that gas can be used to power and operate those valves if they are built and if they are set up that way. So the very first thing I want you to think about is something like a pneumatic type of valve, right? We talked about gases, aka air, that was going inside and was pushing up against some type of plug or some type of flow control device that was allowing flow to take place at a controlled flow rate. So all of that had to do with gases or air in order to make it work. Next, transfer of bulk materials. Transferring, very common. How do we get these big vats, these, huge volumes of stuff sometimes? How do we move that from one vessel to the next? Yes, gravity can do the work. Absolutely, gravity can help us out with that. But gases can also push down, and gases can push liquids out of tanks or solids out of tanks. It really just depends on the manufacturing setup. So absolutely, transferring stuff from one location to the next, gases can be used for that. Number 4, blanket liquids. If you're in the bed and you put a blanket over yourself, what you're doing is that you are covering up and you are protecting yourself from the cold air that might be in the room. blanketing liquids are kind of the same concept. We put a blanket over these liquids, and that blanket will help protect it from the outside or from the room, whatever is going to be there. So it just kind of helps nestle it and snuggle it and keep it warm on a cold winter's day. Okay, you get the idea. It's blanketing liquids, and we'll talk more about that as well. And then number 5, gases can also be used to support cell growth. So if cells are getting used, and this is why we're calling it biomanufacturing, if cells are getting used in these fermenters, in these bioreactors, then we want to make sure that they grow and that they stay living and that they stay healthy. Well, one of the ways to do that, well, they need nutrients, they need some food supply, they need to be able to grow and multiply, and gases can also be used for that same purpose as well. So supporting cell growth is also another option or reason of why industry might use some type of gas in some form or fashion. Notice here I've never identified the gases. So gases is just really a universal term that is used to describe many things. And, you know, this could be air, it could be oxygen, it could be nitrogen, it could be carbon dioxide. I mean, the list just goes on and on and on here, quite honestly. There's tons of different gases that are out there that industry can select and that industry can use. Some of them are more common than others, absolutely. But gas is just the formal kind of umbrella term that includes all of the individual identifications of the gases that we might see or that we're accustomed to. All right. Next up, I want to talk about gases since we're on this roll, and since I just mentioned air, I do want to talk about this concept of compressed air. And compressed air, well, if it's pharmaceutical grade, so that means that this air's got to be super clean. It's got to be clean because it's coming in contact with the pharmaceutical type of drug, or whatever types of material that we are trying to manufacture. So compressed air in pharmaceutical grade air, it's a little different, folks. You know, if I go to Home Depot or if I go to Lowe's and I get me a little nail gun, right? And I'm going to say, okay, well, I'm going to get a nail gun. I need to do some work at the home. I don't want to go through the motions of taking manual labor and kind of picking up a hammer and driving a nail into a piece of wood. I want something that's going to be like an air gun that I can just load up a big sleeve of nails in and just pop, 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 pop. I mean, that's kind of what we want to do, maybe in construction. Well, very often it can't just do that on its own. It's got to be hooked up to some type of air compressor, right? So this compressor is often going to be needed in order to operate these power tools like this. And that compressor is making and compressing air, so that way that air supply can be delivered to your power tool, so you can just simply nail into a piece of wood without hardly any manual labor at all. The air is doing the work, and aka the pressure is doing the work here, right? Well, as you can imagine, this compressed air is very, very dirty, filthy thing. Okay, well, that's what is inside of these compressors. It is not going to be good enough for pharmaceutical type of work, especially if it's coming in contact with something that has to be injected into someone's system, whether it's injected through shots, or whether it's orally taken, or whether it goes through transdermally. It does not matter. It's got to be cleaner than this, okay? So there's going to be pieces and parts that we're going to have to add on to this compressed air in a manufacturing line if we're working within the pharmaceutical industry. So pharmaceutical grade compressed air that we call CAP is often used to transfer material. So keep in mind, this is coming in contact with your APIs. This is going to be part of the transfer system. It's got to be super clean and sanitary because of that. And that's just the 3-letter abbreviation that we use, CAP or CAP. So compressed air, that is P, pharmaceutical grade. So that means that there's got to be some cleanup, there's got to be some filtration that happens on the front end, because what's happening is that the compressed air that's pharmaceutical grade is being pushed into this tank, and that air is pushing against this liquid. So the more air that I push in there, the more pressure that's going to be experienced, and it's going to be able to push those liquids out of those fermenters, out of those tanks, out of whatever holding device that's basically they're getting held in. It's going to push them out as long as, look at this little symbol right here. Look at that. Oh, what a cute little bow tie for a tuxedo. No, that is not. This is a valve. It's a valve that I can twist, and it's a valve that I can turn. And if I open the valve up, then guess what? It goes out to the next part of the manufacturing line, folks. That's how this all works. So this is coming in contact with the stuff that is important, and that stuff needs to be kept clean. So air compressors from Lowe's and Home Depot cannot be used to do that. You need a little bit more sophisticated compressed air for this stuff to work. All right, so that is CAP or CAP. That's compressed air pharma grade. And that can be used to transfer materials, of course. We just talked about how that can work. And the reason is because it's very hard to clean and sterilize some of the pumps that we might use to pump those liquids out. So that is why sometimes air is used in exchange, right? So if I don't want to pump, I'm going to be limited because those pumps have to be able to be sanitized and cleaned because it's coming in direct contact with my stuff. All right, well, if I don't want to go through that, but I want something that is going to be sterile, and maybe compressed air is the way to go. But that compressed air has to be super clean and super sterile before it goes in, and that is our CAP or CAP that we will begin to use. So this is why it is used sometimes to transfer those materials. Pumps are out there. Pumps are a part of the manufacturing line. Pumps are a part of the transfer process, but maybe, just maybe, it's not going to be suitable for what we need. So compressed air can help us transfer stuff from one location to the next. Next up is pneumatic transfer. We've seen that word before. Pneumatic. Okay, I'm learning. Right. Woohoo! I know what that is. And it says it uses compressed gas to blow or Hervé powders from one point to the next. Okay, so really here it is coming in contact with solid the way that this definition is used. So uses compressed gas to blow or Hervé powders. So that means it is coming in contact with powders. Powders might be the active pharmaceutical ingredient. We've got to make sure that it's sanitary. We've got to make sure it's super clean. So therefore, this is a slightly different compressed type of gas than what you would find in normal air compressors that right now might be in your garage or at your house. If not, then you probably know someone that's got one, or you know of a handyman that's got one or something. Okay, so pneumatic transfers are also going to be part of this gas utility world. So just different ways to use it. I mean, that's really all that there is here. That's all that we're talking about. As we're on this concept, we've talked about blanketing the material already. So blanketing the material, again, you put a blanket over yourself to protect you from the cold air in the room. Then blanketing with a gas in some form, in some fashion, can also help protect the active ingredient from the outside room. And sometimes that's going to be very important. The reason is because this will help prevent what we call oxidation. That's a pretty important word. Oxidation, I want you to think of as it can react with oxygen or the air. All right. So let's say that I am driving a vehicle and my vehicle is quite old. And let's say that I'm going around driving on the streets. Yay, yay, yay. And then down the road, I'm going to get hit with a gravel, maybe from a concrete truck or something like that. All right. So I get hit with this gravel and a little piece of paint is chipped off. Okay, now I'm going to have a problem because over a course of time, that paint was helping to protect the metal that my car was made out of. So if that paint is basically chipped off and I get this exposure of metal up underneath, a reaction, a very slow reaction, is going to start happening, and that metal is going to react with the air in the outside environment, and over a course of time, it begins to rust. That is oxidation, right? The same thing's happening maybe with salt trucks. If I have been living in some area with a lot of salt that's been on the roads because they get a lot of snow, a lot of times those vehicles up underneath, if they're not protected the proper way, or if they're not kind of maintenance the proper way, that salt will begin to eat and expose this metal. And that metal, with the oxidation process, can also start to rust. So you've got to be careful. Well, materials can oxidize as well, and we don't want them to react with the environment or with the air inside of the room maybe. So what we do is that we blanket it with some gas to provide a protective little fat layer on top. And I call it a fat layer, even though it's not a fat layer, but that's kind of how I think about it in my head, right? It's the same thing that your body uses for your organs. Fat is good, as long as you don't have too much maybe, right? But fat is a good thing because it's a nice little cushion. It's a protective barrier. So that way your organs don't get damaged when someone pokes you in the back or pokes you in the stomach, okay? So that's actually kind of a good thing sometimes. Well, the compressed gas, if it's used, aka utility, in a manufacturing line, that is providing a little bit of cushion, a protective barrier on the stuff that is the most important in the manufacturing realm. All right. Common gases that are used to blanket materials, you don't quite have to know these, but just to throw out some names, nitrogen and helium and argon are very often used. Nitrogen can be found easily in the air that we breathe. Actually, the air that we breathe is mainly nitrogen gas. It is not oxygen. It is not carbon dioxide that we're breathing out. It is actually nitrogen if you sampled it and did a percent composition of it. Helium, the abbreviation is capital H with an E. Nitrogen is a capital N with a subscript of 2. And argon is a capital A with a lowercase r. Argon is very inert. And inert means it just doesn't react with anything. It's really hard to get it to do stuff. And because of that, we love it, because if it's hard to react, then it's going to hard to kind of mess up with the stuff that we're trying to make and that we're trying to capture. So pretty stable, not reactive, doesn't blow up. There's not a lot of reactions or chemistry that goes on with it. Helium is actually the same thing. So helium is also inert. And we use helium and argon for different purposes in laboratory settings for the same reason. It is inert. It doesn't want to react. They are kind of snooty and snobby, and they're like, ooh, everybody wants to be like me, but I don't want to be like you. Stay away. I mean, that's kind of what they are in my mind when I talk about reactions and how they react and behave with other things. So there's a couple of options to blanket material that we are using on the manufacturing line. Next up is this word called sparge. We've seen sparge before. This is not Marge off The Simpsons. It is sparge. That's kind of what's going on with these types of things. So sparging the material, well, okay, I can go back and kind of show you a picture, and I will. So I'll flip to this, and here we see a diagram. We've seen this diagram before, and this diagram at the very bottom has a sparger. Look at that. Right there. So what's happening is that we've got a gas line, and that gas line, here's the gas inlet, and look, little bow tie tuxedo. No, that's not, Tracy. That is a valve. So I'm going to turn the valve on, and when I turn the valve on, the gas is going to rush in, and the gas is going to there's my sound effects. So it's just going to bubble and churn the stuff that's inside of these reactors, maybe, if that's what we're kind of doing. That's what this diagram is actually kind of depicting in some form or fashion, right? So this is feeding whatever material that's in there some type of gas. And again, I've got different choices of gas, so I'm not limited to anything. It's just gas is a universal term that is used for these types of situations. So many things will need oxygen. So oxygen is pretty common as far as sparging material with. And then carbon dioxide is actually going to be another pretty common gas that can be used for sparging, and ammonia is also another gas that can be used for sparging. So I want you to think of like maybe your ground hamburger meat that you're buying at the grocery store. Most people don't know, but your ground hamburger meat is partly slop. Otherwise, they are using those cuts of meat for steaks and tenderloins and chops. I mean, that's kind of what they are using them for. So they get all these like fatty pieces, all these pieces that people probably wouldn't want to eat. Otherwise, they would be selling it solely as a huge big chunk. And what happens is that they're grinding all of that slop up together and they're mixing in with a little bit of fat. So with that said, what's happening is that you get a little bit of fat that gets pumped into a sample, and then you get a little bit of scraps that you're getting pumped into a sample, and then all of a sudden they're going to squeeze like Play-Doh out of this meat grinder, and they're going to call that hamburger meat. Yum, yum. Oh, gosh, it's so good. Where's the 4th of July? I can't wait before I go through the drive-thru or McDonald's or Burger King and order their little scrap patties that have been mixed with nice and juicy fat. Okay, well, this is kind of what goes on. But the problem here is that when they squeeze and mush this little Play-Doh out of the grinders, the surface area is going to increase a little bit. So most of the time, companies will tend to use ammonia, which is NH3, and they will blanket or sparge that hamburger meat with ammonia gas. And the reason they're doing that is because ammonia can kill things. And we don't want to poison you with the hamburger meat when you buy it out of the grocery store. We don't want you to get sick. So we're trying to kill some of the microorganisms that might be on the outside. So the next time you go and get that hamburger meat from the grocery store, keep that in mind. You are probably getting sparged material that has been sent through some type of device that has encountered ammonia gas in order for the cleanup to happen, because that surface area is quite large. Now, when I say surface area, I want you to think of the little bitty wormy-like structure of hamburger meat. There's a lot of surface on this, right? So there's a lot of contact points from the air that it can reach and that it can touch. But then you'd think of like a big, huge, chunky steak. Well, it's only the surface on the outside and the surface on the bottom and the surface on the sides. Nothing in the middle can be touched. So other than the outside of it, that's what needs to kind of be cleaned, making sure there's no like nasty growth or organisms or E. coli, aka poop, on the outside of that steak. That's what you need to think of when you hear people say E. coli, poop. All right, hamburger meat, a little bit different. Hamburger meat, it is much thinner, it's stringier, it's wormy-like, and there's more contact surfaces that the air can reach to. So that's why that's very important. And that's often why some restaurants do not cook your hamburgers rare or medium rare or whatever the case that you like it. It's still bloody and pink on the inside. They're a little bit hesitant to do that because that's another surefire way that they can make sure that all of these microorganisms are getting killed on the surface. All right. Okay, so with that said, I hope it is lunchtime. And you know what? When you watch this video, I hope that you did have one of those little poop burgers in your mouth. So that way you can kind of think about your life's choices. I'm not telling you to stay away from meat, but I am saying make good choices. So if you go to the meat counter and you're looking at that piece of steak, or you're looking at that pork chop, or you're looking at that tenderloin, or you're looking at that roast, then go for those pieces. You're going to be much happier in the end with those particular types of choices versus something that's a little bit scrappier, mixed in with a little bit of fat, squeezed out through a little bitty grinder that looks like little red worms that they are pumping ammonia gas and everything on the outside and then wrapping it up into a package prim and proper for you to buy. So just keep that in mind the next time you go through those processes and through those decisions in the grocery store. All right, so in the next video, we'll pick up from there. I think I've lectured you enough about food, but in the next video, we'll continue to talk about gases and utilities. So I'll see you then.